I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 9th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and smash the like and subscribe button. Ring the bell. You'll get automatic notifications when we post the videos, typically on Sunday evenings. All right, let's get to work. We start by looking at significant wave heights for the North Pacific Ocean. We see a small cutoff low generating 16-foot seas aimed pretty well, in fact, at Hawaii. We see fragments of two other gales, or low pressure systems at least, trying to create some seas, and again, both about 16 feet, but not really aimed at either Hawaii or the U.S. West Coast, so they're of no real interest. All right, let's start looking at upper level winds. We're looking at winds at the jet stream level, up about 30,000 feet. These winds help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push in the jet to the south. So here we have the jet stream pushing off Japan, pretty much over the Kuril Islands, just off of Kamchatka, and then north up into the Bering Sea. The Aleutian Islands are right here, so it's not doing a whole lot. But then the jet falls south, creating a little bit of a circulation here. This is actually a trough, and of course a trough, if it's deep enough, helps create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. Low pressure, if it's deep enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface and produce seas. And seas, as they radiate away from the fetch area, eventually turn into swell. And swell, when it hits your beach, turns into surf. All right, so we have a very pinched, almost fully cut off trough here just north of Hawaii, but as we know, there's some sort of seas being generated here, but the most of the jet is just tracking north here and up into Canada, not offering a whole lot. In fact, as we get into Monday, the 10th of October, the low becomes fully cut off, and once it gets starved of energy, it starts falling apart. But then magically, on Tuesday, the 11th of October, it taps jet stream level energy again, and winds up to, about 150, 160 knots start falling south into the jet, and that creates yet a new trough, again very pinched, but possibly generating some sort of seas, and then pushing off to the east and fading. But behind that, yet another low or another trough. Now this is just a very gentle trough right here, starts forming, digging deep into the Northwest Pacific on Friday the 14th of October, and then continuing off to the east into Sunday, and behind that, yet another trough looks like it's forecast to develop. If all that happens, the jet sinks to about 40 north, which is exactly where it should be for this time of year, and theoretically, we could be in business if enough wind energy gets pumped into the jet from, drumroll please, the active phase of the MJO. We'll see about that in a minute. So let's look at the effect of those winds on the ocean surface, or at least the effect of the jet stream on winds at the ocean surface. So as we mentioned, we think there's some sort of a low, just Hawaii's right there, north of Hawaii, and there is, producing 25, almost 30 knot north winds aimed at the islands, probably producing some seas. And then another low here as we suspected, another low here as we suspected, but nothing particularly strong, nothing particularly interesting, and all that is expected to fall apart until we get into about Tuesday or Wednesday, the 12th of October, when the jet starts falling south again, and lo and behold, 35 to 40 knot winds start again being generated, targeting the Hawaiian Islands pretty well, and then lifting off to the northeast, maybe getting some traction. And yet another low builds a better one, actually, off Kamchatka, the Aleutian Islands right here, dateline right here, with 30 to 35 knot winds sweeping across the North Dateline region, targeting Hawaii and the U.S. West Coast pretty well, but pretty far away, and winds not super strong, so probably kind of a minimal swell producer. Some sort of fetch in the 25 to 30 knot range continues into even the weekend. That's good news. Maybe more swell being generated. And then after that, now this is interesting, another little bit of, it's actually, we suspect, tropical energy, just weakly tropical energy that develops Saturday, supposedly off Japan, starts tapping that jet stream level energy also as we get into late Sunday, early Monday, the 17th of October, and maybe something will come from that. So the North Pacific is trying, but not really quite getting there yet, but something is better than nothing. All right, so let's look at the effect of those winds on the ocean surface itself. We're going back in time to 18Z on Friday, let's say 11 o'clock on Friday morning 2 days ago. We know low pressure was in the Gulf of Alaska, and it started to regenerate some on Saturday. Not much, but just enough to generate 19.8-foot seas right there, targeting Hawaii, and continuing into Saturday evening and then fading out. The point being, oh, there we go, that's the end of that. We see another pulse of swell energy forecast pushing towards the Hawaiian Islands. And that is to arrive pretty much on Sunday night into Monday morning. Nothing huge, just a continuation of the surf that's been hitting the Hawaiian Islands. I mean, surf heights right now are couple feet overhead, maybe pushing double overhead at top spots, north-facing breaks on the north shore of Oahu. So certainly there is surf, not ideal, not perfect, but there are waves, certainly better than the mainland. Anyway, as we get into Wednesday, then we know another low is forecast to form, and it does, generating 21-foot seas, maybe pushing 22 feet barely on Wednesday night, and then fading out. And then another low starts developing off Kamchatka, generating 22.7-foot seas, and pretty much holding in that range till sometime into late Friday. And then still 18, 17-foot seas sort of thing through the weekend, so that you can see swell pushing towards the Hawaiian Islands and the U.S. West Coast. And then we know right here, another little low trying to organize, not doing very much yet, and a week out, but it gives us some hope. So looking down south, we're going back a week ago, Sunday, the 2nd of October, little low pushed under New Zealand, generating up to 30-foot seas right here, and then faded out. Swell from that system is pushing north. It's already hitting the Hawaiian Islands. Nothing huge size-wise, but definitely rideable. And swell from that is also supposed to push into California starting later on Monday, peaking like Tuesday, Wednesday sort of thing. Again, nothing huge in size, 2 feet at 16 seconds or something like that. Waist high, chest high, maybe a little bit higher at top spots. Rideable surf. And then looking forward after that, really nothing else occurred in the South Pacific. And then looking forward for the coming week, we're just scanning here real quick, looking for any meaningful seas, we'd say more than 26 feet aimed off to the northeast. Supposedly on Friday the 14th of October, a little gale is supposed to generate 26-foot seas in the central South Pacific, pushing off to the northeast with seas, what is that, up to about 34 feet. This has been on the models a couple days, but it seems to be downgrading the closer we get to it, and we're still a week out, so we're kind of not very optimistic that anything's going to come from that. The focus now is slowly and surely turning to the north. We're waiting for something real in the north, though, to get our attention. Checking out winds and potential for wind swell in the North Pacific, focused on California, Hawaiian Islands here. Light wind pattern for the most part is forecast for California until we get into Tuesday. A little fetch of 25-knot winds off of Cape Mendocino. That should generate some wind swell pushing south and Tuesday into Wednesday. Certainly low pressure in the Gulf of Alaska targeting the Hawaiian Islands. You can see the 40-knot winds right here aimed at the Hawaiian Islands. But locally, relatively light, maybe southerly winds. Nothing too intense. And then, but notice, as we get into Friday, low pressure starts trying to creep closer to the U.S. West Coast. We'll see how far it actually gets and then take a significant grain of salt with that. We see weak low pressure right up to the Oregon coast on Sunday and almost pushing in to Oregon Sunday night and towards California, maybe Cape Mendocino, but nothing real. And then this low pressure system out here theoretically could tap some of this energy. We'll have to see how that plays out. The all-important rainfall forecast. Blue is rain, California right here. We're looking for any signs of cold front, low pressure driven precip coming into California. And you can see there's just this steady high pressure system off the California coast. Not unusual for this time of year. You can see the low pressure trying to organize. We're almost a week out now. It makes it almost to Cape Mendocino, maybe some showers if you believe the model. We're 180 hours out and just kind of dissolving, maybe 200 miles off the coast, something like that. But we'll see. Maybe something better to come in the next week or two. Looking at the snow forecast dashboard for the Pacific Crest Trail at where it intersects with Tioga Pass Road. That's in high country of Yosemite. No snow forecast. Snow levels are the freezing level. Today, about 12,000 feet. Maybe dipping some tomorrow and the day after that down to about 11,000 feet. Then leveling out somewhere around 12,000, 12,500 feet. Maybe dipping some to the 11,000 foot range as we get into October 17th, 18th, 19th sort of thing. But still, no big sign of a trough pushing into the coast. You'd see the temperatures dip, the freezing line dip way down here. Nothing like that. Still, sort of typical for right now, the first real rain, fall rain, at least in the San Francisco Bay Area, is somewhere around October 15th out to the Halloween time frame. Yes, we did have rain, what was it, 2 weeks ago, something like that, and it was pretty good early season. We need more, but it was a start. We're looking for it. Nothing for the next 10 days, though. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation and the El Nino Southern Oscillation? We start by looking for signs of the active phase of the MJO. There's two phases to the MJO, the active phase and the inactive phase. Active phase on one side of the planet, inactive phase on the other. They rotate west to east around the planet. The active phase is effectively a low pressure system. It takes energy, warm heat energy from off the ocean surface, pumps it up into the atmosphere, which in turn feeds the jet stream. When you have more energy in the jet stream, that in turn feeds the storm track. You get more storms, more precipitation. Also, when the active phase of the MJO moves over the West Pacific, that can dampen trade winds, if not cause them to reverse. That can take warm water in the West Pacific, start pushing it east under the equator from the West Pacific to the East Pacific. That ball of warm water is known as a Kelvin wave. Kelvin, if you have successive active phases of the MJO, they can create successive Kelvin waves. Eventually, the Kelvin waves erupt off of Ecuador and the Galapagos, and that can in turn start warming waters off there. That is atypical, not normal, and that can kick off El Nino. Of course, the inactive phase of the MJO does the exact opposite. Steals energy from the jet stream, dampens the storm track, and enhances trades when over the Pacific, and that does nothing to support storm development. All right, so we're going to take a look at data from the TAO buoy array, a series of buoys strung across the equator from the East Pacific, here's the equator right here, to the West Pacific. Those buoys are used for monitoring El Nino, but they also have wind sensors on them. We just look at the arrows. The longer the arrow, the stronger the winds. The direction, pretty self-evident. East trades, strong in the East Pacific. East trades, strong in the Central Pacific. East trades, strong in the West Pacific. But it's not those average wind speeds. It's the anomalies. Are those winds stronger or weaker than normal for this time of year? Looking at the arrows here in the East Pacific, looks like it's pretty normal. Central Pacific, trades definitely stronger than normal. And over the all-important Kelvin wave generation area, the West Pacific, trades definitely stronger than normal. This looks like the inactive phase of the MJO. Let's dig a little deeper. 850 millibar zonal wind anomalies. These are winds up about 4,700 feet. All right, this is the whole planet on one chart. The date line runs right up the middle here at 180 west. So that's the West Pacific starts about 135 east to about 170 west. That's what we call the Kelvin wave generation area. Okay, we see a lot of blues all down the middle of the chart. These are zonal wind anomalies, the differences from normal for this time of year. Blues, purples are easterly anomalies, the inactive phase of the MJO. The forecast per the GFS model for the next week, stronger than normal, easterly anomalies, inactive phase of the MJO in control. The reds and yellows are westerly anomalies, but they're over Indonesia, the maritime continent. And where they have been, this is the typical La Nina pattern. East anomalies over the Pacific, west anomalies over either the far East Atlantic or over the maritime continent. And wherever the west anomalies are, That's where the low pressure is, and that's where the surf is, and that's where the rain is. This picture tells the story perfectly. Looking out 2 weeks, this is outgoing long wave radiation forecast, another word for cloud cover. The blues is more cloud cover than normal. Oranges and yellows, less cloud cover than normal. So where there's more cloud cover, that's where low pressure is. So you can see it right here. And the areas that are yellow, less cloud cover, that would be high pressure. That'd be the inactive phase of the MJO. Now this is from the statistic model. Let's get ourselves oriented. South America there, Central America, Hawaii, West Pacific, there's like the Philippines, New Guinea there. Dateline right there. The equator right there. The area that matters right here. 5 degrees north and south of the equator from 170 west to about 135 east, the Kelvin wave generation area. So supposedly the active phase of the MJO is building over there, forecast to hold for the next, this is 5 days at a time, so out the next 2 weeks. That's good news. The dynamic model, the GEFS model, GFS ensemble model, pretty much painting the same picture. Strength-wise, just about the same at the end of 2 weeks. So theoretically, things are supposed to get better. Phase diagram charts for the same two models, statistic here, dynamic model here. The MJO moves from west to east, from the Indian Ocean to the Maritime Continent, to the West Pacific to the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now, so over the Maritime Continent, just starting to bleed into the West Pacific. The further the dot is away from this circle, the stronger it is. So a very, very weak active phase of the MJ over the Maritime Continent. 3 different potential outcomes. The best one shows the active phase 2 weeks from now. This is a 2-week model. You can count the dots. There's 14 of them. Has the active phase modestly strong in the West Pacific. The dynamic model suggests, well, maybe a hair bit stronger and not moving quite as fast. So the two models pretty much in sync. And this is the GFS model down at the 925 millibar level. I think that's, 1,200 feet or something like that. The equator is right here. Okay, this is the Pacific Basin. 5 degrees north to 5 degrees south. The area we're interested, right in this box right here. Easterly anomalies are the purples, oranges and yellows are westerlies, so this looks like the inactive phase of the MJO, and we're just going to sort of blast through this over time. And you see, yes, there's those easterly anomalies building as we get into October 13th in the Kelvin wave generation area. But then theoretically, as we get further out, that's supposed to start fading right about there. We're out at October 20th, something like that. And then westerly anomalies start building, almost filling the Kelvin wave generation area. Now weak, not particularly strong, and holding on through October 23rd. That would be a step in the right direction. So next we go out 40 days. This is a statistic model, upper level model up at the jet stream level, but showing areas favorable for precipitation. The greens favorable for precipitation, oranges and yellows not favorable, dry air. So this could loosely be equated with the active phase of the MJO. And let's get ourselves oriented. South America here, Central America, Philippines, New Guinea, the equator right there, dateline roughly there. So this is the area we're interested in. So according to this model, weak active phase of the MJO in control, making its way across the Pacific through about, the first week of October, and then the first week of November, and then the inactive phase, dry air, moving in for November till at least mid-November, but it looks like the active phase may be building in behind that. So then this is 850 millibar zonal wind anomalies from the CFS model going out 1 month from October 8th to November 5th. This is the whole planet on one chart, date line up the middle. Kelvin wave generation area starts about 135 east, so right in this area, right here. Now this is the little bit of an interesting thing. You'll see it. Just keep in mind how this one looks and then how the next model looks. They're both the CFS model, and it's a little bit of a head scratcher. Anyway, what this suggests, the blues are easterly anomalies. No big surprise. We know we're there. Here's the inactive phase of the MJO, and I presume it's going to just make it the whole way across the Kelvin wave generation area, though this model doesn't actually show it, with easterly anomalies peaking about, 3 or 4 days out. Now, the solid contour here is the active phase of the MJO. And that's supposed to push across the Kelvin wave generation area, producing westerly anomalies, filling almost half to 2/3 of the Kelvin wave generation area into about the October 22nd, something like that, and then fading. And according to this model, easterly anomalies start rebuilding as we get into early November. Now let's check out this other model. Now this model is the same 850 millibars zonal wind anomalies. Goes a little bit further now, north and south, 7.5 south to 7.5 north. Kelvin wave generation area, or I'm sorry, the date line runs right up the middle. Kelvin wave generation area. Now this is the forecast up here. This is past performance here. Kelvin wave generation area starts about 135 east, so from here to about here, and this goes out 3 months. All right, so you can see easterly anomalies forecast holding till about mid-October, and then after that, westerly anomalies, light maybe, but steady westerly anomalies building, taking over the entirety of the Kelvin wave generation area into at least January 5th. In fact, on November 5th, this is when the previous model said easterly anomalies are supposed to be building. If you look at this real close, well, it looks like neutral to westerly anomalies. So there's a bit of a disconnect between the two models, and they're the exact same models. Cannot explain the difference here, but we'll take a look and see what's driving this. This is the same active phase that we've been talking about for months now, is supposed to take over, pretty much fill the Kelvin wave generation area by October 20th, something like that, dragging westerly anomalies with it. Yes, easterly anomalies will persist off the California coast to maybe a point south of Hawaii, something like that, but westerly anomalies just get more and more growth, reaching the whole way to the California coast as we get into the Christmas time frame. And yes, a inactive phase of the MJO is forecast behind it, but literally no easterly anomalies forecast with it. Looks like the demise of La Nina. Now we overlay the low pass filter. This is the low pressure, high pressure bias. The dotted contour, high pressure bias. This is what's been driving La Nina in the Pacific. See, it's been centered smack over the date line. Has two contour lines right now, but as we get into the Thanksgiving time frame, the second contour fades, and as we get to Christmas, the first contour completely dissipates, and this is the low pressure bias. This is your El Nino indicator. You see the leading edge of it. If anything, it's retrograding for about another week or two. After that, it stabilizes, and then it just starts pushing to the east. So right there, where is that? That's about somewhere around roughly 150 east. That's almost halfway through the Kelvin wave generation area. Now, that is 3 months out. Do you believe a model that goes 3 months out? No, but this model has been rock solid. In fact, last week when we did this video, this same sort of pattern was suggested. Maybe it's slipped a couple of days, but still, right around the Christmas time frame, this all looks like the La Nina signal is supposed to completely dissipate. I think the real key is going to be what happens in the next 2 weeks. In fact, if I were going to title this video, I'd say 2 weeks and counting, because if in 2 weeks from now, we get westerly anomalies, and they can hold for a couple of weeks after that 2-week countdown ends, and we don't get a significant rebuild of easterly anomalies, then I would say La Nina, at least the underpinnings of it, are all but gone. Now that's a lot of hype to swallow, and I don't want to overhype it. That's exactly what we don't want to do. But sometimes I do get excited when I see that a 3 or 2.5 year long weather pattern that has not been favorable for precipitation and has not been favorable for surf is looking like it's going to break down, and that breakdown might happen starting 2 weeks from now. I can't help but get a little bit excited, so please forgive me, but I will try not to overdo it too much. All right, looking forward, what's going on down in the ocean? That's also a predictor or an indicator of what's going on from an El Nino, La Nina perspective. We're done with the MJO. We're through with that. Now we're looking long term. El Nino, La Nina, we're talking 3 months, 6 months, a year, 2 years out. I know, wild speculation, but you can kind of get some reading from the tea leaves by looking at the data that we're about to review. All right, so we start by looking at temperatures down in the ocean. This is the West Pacific here, East Pacific here. Those little X's there. Those are the anchor lines on the buoys anchored the whole way across the equator across the Pacific, used for monitoring El Nino. The X's themselves are actual sensors on the anchor lines. You can see there's probably X's that are supposed to be here, but there's sensors that are not working. All right, so these sensors relay their data to a central processing facility daily or twice a day or whatever, and then you apply a model because you see there's pretty big gaps in between all these different anchor lines, but you can get a profile of what's going on subsurface temperature-wise. The 28-degree isotherm right here, 28 degrees centigrade, that's warm water, right where it was last week, about 175 east. The 26-degree isotherm, I think it was hanging right around 150, something like that. The 24-degree isotherm, well, I mean, it had been back around 130 or so, maybe making a little bit of eastward progress. Pretty stable state right now, but it's not the actual temperatures. It's the anomalies, differences from normal for this time of year. The warm water, there's a ball of warm water. This looks like a Kelvin wave, and it would be if it had an active phase of the MJO over top of it to get westerly anomalies going here to then get some momentum to push this to the east. But we haven't had the pleasure of an active phase for a while. We know one is coming in a week or two. Maybe that will help move this off to the east. So there's this dividing line. In fact, let's get ourselves oriented. Right there is 155 west. So the dividing line has been right around somewhere between 150 and 155. Notice cooler than water off to the east, driven by, of course, easterly anomalies and upwelling here. All right. We need a westerly wind burst and a Kelvin wave to start nudging this, bulldozing this up to the surface, get it out of there, and then try to get some sort of a river of warm water moving. That's one set of data. Here's another way of looking at the same thing. This does, I don't think it uses any of the above data. It uses a totally different approach. It uses sea height data, and we'll get into that in a second. But it's painting the same general picture, this hard dividing line between right at about 150 west, and that's where it's been, give or take a degree or two. Temperature is much warmer. You can see massive amount of warm water here. What is this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is like 4.5 degree positive anomalies, and equally as cold negative anomalies on the other side of the brick wall. We need the brick wall to move off to the east. Sea level anomalies, all right? We've discussed this before. This is not temperature data. This is the height of the ocean. Take a satellite, beam radar down, look for tiny differences in the height of the ocean surface. That is, you take the waves out, take the wind waves out, even take the tides out. And is the sphere of the ocean, is it higher or lower than normal? If you have cold water at depth, cold water contracts. When it contracts, it'll leave a divot on the ocean surface. Likewise, if you have warm water at depth, it expands. When it does that, it pushes the ocean surface up just a little bit, a couple centimeters. That much. That's all it takes. This guy can sense that. So, positive anomalies, the oranges and yellows here. And the interesting part is they make it right to there, which is right about 150, something like that, just what we were seeing in the other charts. So warm water, you can surmise warmer than normal water at depth is somewhere like right along in there, something like that. And then minus 15, minus 10, minus 5. Here's your colder than normal water right here. One can assume easterly anomalies pushing this way, trying to create upwelling, pushing into this direction, but not making it because there's a lot of building up warmer water in the west. And yet, one more way to look at the same thing. Upper ocean heat anomalies. Temperatures in the upper 300 meters of the ocean surface. West Pacific here, East Pacific here, going back in time a year ago. This is the second of three. There's 1, 2, 3 upwelling events that set us up for La Nina last winter. We did get an active phase of the MJO that tapped this warm water here in the west, created a Kelvin wave, pushed across the Pacific, warmed things up a little bit, but then in March, we got the typical upwelling thing going. La Nina rejuvenated. Another Kelvin wave tried to organize in the spring to early summer part of this year. Didn't make much progress. We got another upwelling phase here in the July, August time frame, and still in control as of right now. We're looking at the back edge of this one. Yeah, it's hanging right around 150, 150, and we don't see really any real eastward movement. We see there used to be two lobes. Seems like this lobe is getting pushed into the more eastward lobe, and they're consolidating, not getting any colder, but not moving anywhere either, suggesting that the very warm water here in the West Pacific has not made any progress yet. Again, it needs a Kelvin wave to do that, to give it momentum off to the east. We think that's coming. Upper ocean heat anomalies, same deal, only this is from the date line and points east. You can see cold water last winter, very cold, down to minus 1.8 degrees. We had a Kelvin wave in February, another one in the June-July timeframe, and then here's our most recent cold spell. Maybe temperatures are coming up just a little bit, but not really. Pretty much stable for the moment. Sea surface temperature anomalies. This is the temperature of the ocean, the differences compared to normal for this time of year. A clear La Nina signal indicated. The blues colder than normal temperatures, and let's get ourselves oriented. Chile, Peru is all South America. Central America here, Hawaii there. The equator is 0. The images don't quite line up. That's 0 also, so you get this kind of mirror image thing going on, but you get the general idea. Very cold water. This is that pool of cool water in the east getting forced to the surface, upwelling, getting caught by the trades here and dragged off to the east. But most of it focused right here, just basically off the Galapagos. The official El Nino monitoring region starts at 120 to 5 degrees north and south of the equator out to 170 west, so right here. So that's the box, and just eyeballing it, it all looks colder than normal. No big surprise. Sea surface temperature trend for the past 7 days. The good news here is you can see the reds and yellows. That's warming. There are some pockets of cooling, but in general, I'd say the balance is towards warming rather than colder. All this suggests is that the temperatures are cold, but they're not getting any colder. If anything, maybe they're giving up a wee bit of ground. And then the backed off view, you can see it here. Again, there's that cold upwelling right by the Galapagos, and generally colder temperatures all along Peru. Typical La Nina signal. The official El Nino monitoring region, right here, 170 west, 5 degrees north and south to 120. So right in there you draw a box. And for the most part, nary any warm water to be found. Sea surface temperature anomaly trend. This is in the Nino 1.2 region, right up there by Peru, Galapagos, and Ecuador. Temperatures today, minus 1.89 degrees. That's really cold. The La Nina threshold is way up here at half a degree below normal. So we have a long ways to go, and the trend has been down. Looks like, well, it's bottomed out only because it can't get any colder. But that's not the official El Nino monitoring region. The Nino 3.4 region is today's value, 0.822, 822 thousandths of a degree below normal. Temperatures, they bumped up a little bit as compared to, well, back in August and September. So sort of doing okay. The past day heading in the wrong direction, but we'll see how that all plays out. Again, the cutoff, the La Nina threshold is way up here. So we need a significant change to happen if we're going to get out of La Nina this winter. So what does the atmosphere think is going on? Well, we look at the difference in pressure between Darwin, Australia, and Tahiti. If pressure is lower in Tahiti, Tahiti's in the Pacific, Darwin in the Indian Ocean, then the index goes negative. Today it's positive, plus 2411. We want to see this negative because when it goes negative and stays negative for a week or 2 or 3, then that's typically the sign of the active phase of the MJO. If it stays longer than that, then it also suggests perhaps a trend towards El Nino. But looking at the values, well, we were up at plus 37.19 just a few days ago. That was quite warm. Plus 35 back in the end of September. And you see it hasn't been anywhere near negative for a month. Clearly, at a minimum in the inactive phase, probably in La Nina. The 30-day average, this is your active-inactive MJO phase indicator, going up 20.18. And just looking back, well, we've gone up from 10 a month ago, up to 20.18 today. So clearly the inactive phase in control. The 90-day average is your El Nino La Nina indicator, plus 13.16, and it's going up from about 11.47. So if anything, a little bit of reinforcement towards La Nina. We don't like that. Here's the 30-day SOI graphed out so you can see what the trend has been. Back in 2020, so here's the zero, here's neutral. Anything down below, somewhere around 10 is El Nino, so say very weak, neutral to weak El Nino back 2 years ago. And then here was the beginning of La Nina. The inactive phases of the MJO, these upward spikes dominating, driving numbers up at 17. We were up at 23 in, what was that, March, April, May, maybe something like that. And now another upward push. When will this ever go down? We're not sure, but we have our thoughts. Sea surface temperature forecast for the official El Nino monitoring region, the Nino 3.4 region. All right, the solid line is confirmed data to date. So this is somewhere in early October, maybe October 5th or 9th or somewhere in there. Temperature 1 degree below normal. The forecast, this is raw data, suggests temperature going down over the next week, bottoming out. So this is October 15th right here, down to about 1.15 degrees below normal, holding through the end of October, and then starting an upward climb. The La Nina threshold right here at half a degree, somewhere in mid-February, looks like, or maybe even early February, we are out of La Nina and we start moving into neutral territory and the high end of neutral territory as we get into the late part of spring, early summer, for the raw data. But it is the PDF corrected version right here. This is probably the closer to realistic average. There's some cold biases in the CFS model. This suggests that we're pretty much as cold as we're going to get right now, maybe down to 1.05 degrees below normal, hanging there for October and November, but then starting to ease up. Let's see, so the 1 degree line is right about there, something like that. So above the 1 degree line maybe in November, and then heading up from there, and as the time we hit February, we're officially neutral and heading up beyond that. So this suggests, just like what we've been saying for weeks, this really hasn't changed at all. Somewhere around the February timeframe, we think there will be a significant change in the jet stream, in the weather patterns that will favor storm production. All right, so for right now, there is some small southern hemiswell coming in. The final, we'll call it decent pulse of southern hemiswell from New Zealand is hitting Hawaii and bound in for California starting later tomorrow and peaking like Tuesday, Wednesday. Nothing huge, but rideable and fun. The North Pacific supposed to kind of wake up, not much, but at least a more consistent push of 13-second period swell, not big. Focused mainly on Hawaii initially, but we sort of suspect that maybe a week and a half, maybe even 2 weeks out from now, that the focus will also start turning towards California, at least north of Point Conception, and the Gulf of Alaska will wake up some, nothing huge, but at least some surf, and maybe even a smidgen of rain pushing in as well, but that is kind of a far-out hope. Beyond that, the model's pretty much unchanged. We'll say it again. The 2-week time is the critical time. We think the active phase of the MJO will set up, create westerly anomalies, and 2 weeks from now, the West Pacific might start coming into play, at least in terms of the active phase of the MJO, feeding energy to the jet stream, and pretty quickly after that, storm production and our fall pattern could wake up, maybe. That said, looking even further out, we think it'll still be kind of a hit or miss thing until we get into, at the earliest, around Christmas, and possibly as late as mid-February, before potentially we get into a semi-normal pattern with La Nina breaking down, the jet stream kind of waking up, westerly anomalies in control of the Kelvin wave generation area, and things sort of returning back to a quote-unquote normal period, including rain into California and snow up in the Sierra. That's a big maybe, though. It's a ways out. But we'll keep our eyes on the most closest to home next milestone, which is 2 weeks from now. We'll see. Fingers crossed. We're just hoping that it happens. All right, that's it for this week. If you enjoyed the video, give us a thumbs up, like and subscribe, ring the bell. You get automatic notifications when the videos are posted on Sunday evenings. And other than that, we'll do it again next week. Same time, same channel. Thanks for watching.